Good afternoon. This is the fourth class in chemistry for HSC first year. Today's topic is line hydrogen spectrum. What is this? It should be here from current page. Okay. Linus spectrum or atomic spectrum. So when in a electron, according to the Bohr's atomic model, there are some orbit electrons move in a some stationary state surround the nucleus. This stationary path is called orbit. So when this orbit, there are first orbit, second orbit, third orbit, fourth orbit, sixth orbit. There is a orbit, and these are called energy level. First energy level, second energy level, third energy level. These are called like this is the nucleus. This is the first energy level. It is lower energy level. Lower energy level, first orbit or first shell. Second energy level. Then third energy level. Okay. So in a electron in a like this the lower energy level. Electron in a lower energy level, when it gain electrons energy, when it gain energy, it absorb energy. This electron jump to the higher energy orbit or energy shell, higher energy level. When energy source is removed, this electron again jump to the its own at first state. It's at the beginning state, again jump to the lower energy state. That time it emits radiation or energy. This energy is called a spectrum. This energy or ray is called a spectrum. This is called line spectrum. Okay, this topic is atomic spectrum is formed because the movement of electrons. If an atom is heated at great temperature, making it gaseous, then electromagnetic emission fall in it. Electrons leave from its outermost orbit as soon as is removed. Electron emits the absorbed energy and come back to the lower orbits. The emission energy is equal to the absorption energy. This emission energy or ray is called atomic spectrum or Linus spectrum. Have you understood what is the Linus spectrum? When atomic spectrum is formed because of the movement of electrons. If atom is heated at a great temperature, if atom is made at a great temperature, it gaseous, it become gaseous, and electromagnetic emission fall in it. Electrons leave, then it move to the outermost orbit. Electrons leave from its orbit as soon as so energy source is removed, and it back to its lower orbits. That time it emits energy emission occur. This emission energy is equal to the absorption energy. This emission energy or ray is called atomic spectrum. আমার কাছে তো দেখে শুনে যাবে। What is atomic spectrum? Linus spectrum. Like when in an orbit, in a different orbit, stationary orbit, electrons stay. If in a lower energy orbit, electron contain like when the when electron the lower energy orbit to nucleus, and lower energy orbit to when it gain energy, when in a energy source, when it gain energy at height, energy gain, it absorb energy and it move to the higher energy orbit. Electrons jump to the higher energy orbit. If when energy source is removed, this electron jump to the lower energy orbit again. That time it emit radiation or emission energy emission occur. Delta H emission energy occur. This emission energy is called ray. This ray is called Linus. Okay, thank you. So atomic spectrum is a formed because of the movement of electron. If atom is heated in a great temperature, making it gaseous, then electromagnetic radiation emission fall in it. Electron leave from its outermost orbit. As soon as energy source is removed, electron emit absorb energy and come back to the lower orbits. The emission energy is equal to the absorption energy, and this emission energy or ray is called atomic spectrum. Okay, Linus spectrum of hydrogen atom. If electricity is passed at low voltage discharge tube containing hydrogen gas, if electricity is passed a tube containing hydrogen gas at low voltage discharge, emission of colored line take place. Emission of colored line take place. Reddish to pink take place. An analysis of this emission through a spectroscopy. Give a spectroscopy is a study branch through a spectroscopy gives a series of colored line, red to violet. This series of line is called hydrogen line spectrum. This series of line is called hydrogen line spectrum. Hydrogen line spectrum, which show the characteristics of the line spectrum of other atomic spectra. Other atomic spectra which show the characteristics. So when this is a gas discharging tube containing hydrogen gas. Gas discharging tube containing hydrogen gas. If electricity is passed here, if electricity is passed at low voltage, the emission of color take place. Emission of color take place. The like in a prism, emission of color take place. This is the reddish to pink. This emission of violet to red color emission of take place. This is called emission hydrogen line spectra. This is called hydrogen line spectra. Hydrogen emission spectrum. Look this color. This emission color is equal. All atomic spectra is show also this like this color. Like characteristics of color show this. Okay, next is this is the hydrogen emission spectrum. Okay, when electrons of many hydrogen atoms, electrons of many hydrogen atoms get excited by absorption of energy from the energy source, they tend to come back to stable energy state, ground state, by emission of light and line spectra result. If electrons come back to the first energy level, the line obtained a spectral line. If the electron is come back to the first energy level, the line obtained is called Lyman series. Like if the if the electrons of many hydrogen atoms, if the spectra of many hydrogen atoms like these things, সার্কুলার কোনটি পাওয়া যাবে না, এটা এটা এই এটা এটা তো দেওয়া যায়, সুন্দর হয়েছে। ওকে, ভিতরে দেওয়া যায় না, এটা কি আনা যাইব না? এই তো একটা পাইছি। ওকে, এখান থেকে একটা পাইছি। এটা হচ্ছে না। আচ্ছা, একটা দিয়ে শেল দেই, আমি এরকম বানাই। Sorry, this is not easier here. Draw. If electrons of many hydrogen atoms get excited, so it become by absorption of energy from energy source, then tend to if and back to the energy state, ground state, by emission of light. If electrons come back to the first energy level, if electrons all back to the first energy level, this is the first energy level. If electrons back to the first energy level from this is the n1, first energy level n1, back to the from n to n3, n4 to n1, n5 to n1. If all electrons back to the various energy levels to n1, ground state, line obtains. This is line obtains. It's called Lyman series. This is called Lyman series. This is called Lyman series. If electrons back to the energy level 2, this is the energy level 1. If back to the energy level 2 from 3, 4, 5, 6, 7, 8. Sorry, this I should give another places. If back to the energy level 2, from 2 all back to the ground state is excited state. Ground state here is a 2. Ground state is here is 2. Excited state from 3, 4, 5. If back to the electrons back to the ground state 2 from 3, 4, 5, 6, so on, and form a line is obtained. This line is called Balmer series. This line is called Balmer series. Balmer series. Okay. If electrons if the ground state is now, if the ground state is 3, this is the 2. If the ground state is 3, if electron move from excited state 4 to 3 or 5 to 3 or 6 to 3 or so on, then form a series. This is called pass chain series. This is called pass chain pass chain series. Okay, now I am showing this thing here in okay, if the ground state is 1 and excited state are 2, 3, 4, 5, 6, 7, so when 1 all come from 2 to 1, 3 to 1, 4 to 1, 5 to 1, 6 to 1, 7 to 1, 8 to 1, then from a lines obtained. This is called Lyman series. And if ground state is 2 from 3 to 2, 4 to 2, 5 to 2, 6 to 2, 7 to 2, 8 to 2, 2, then form a lines. These are called Balmer series, like then past chain series, bracket series, found series. Okay, if the ground state is 1 and excited state are 2, 3, 4, 5, 6, form Lyman series. N1 is ground state, and this color is show, this radiation is show, emission is shown, the spectral line is shown in the electromagnetic radiation region, in the ultraviolet region this color is shown. Okay, do you see the ray, this color we show, do you see the color ultraviolet, student? Lyman series, do we see by the naked eye? Ultraviolet light, do we see? Hello student, are you listening me? Do you see the ultraviolet light?
Yes, sir.
No, thank you. If the electrons come back to the ground state 2 and from higher state 3, 4, 5, 6, 7, then from visible state, visible region, do we see this color visible? Visible color we see. Do we see visible color? This region, Balmer series. Balmer series, which spectral line show? Main spectral line in show in the electromagnetic spectrum, electromagnetic radiation in the visible region. Okay, this is visible region we can see. देखिए roll number কয়জন আছে? Rule number 1 below, it is can be shown visible region, Balmer series.
Yes, sir.
Yes, thank you. Next, past chain series. Past chain series infrared. Do we see this line infrared?
Yes, sir.
This ray we don't see. Infrared we don't see. Infrared don't see. Infrared don't see. So we only can observe Balmer series. Balmer series we can see. Okay. This is the ground state is 2, excited state are 3, 4, 5, 6. This series only Balmer series we can see. So there are 5 series: Lyman series, Balmer series, past chain series, bracket series, found series. Okay, scientists put forward a formula explain the aspect of hydrogen atom in the following way. This is called Dattari. Okay, scientists reads give a formula to explain the Linus spectra of hydrogen atom in the following way. You give the 1 by lambda divided by, or nu, you can use nu or Rydberg constant RH this one is N1. N1 means ground state, from where energy is electron is come or removed. N1 means, hello student, N1 which orbit? Here electron in. N2 means from where electron come. Electron come from, it is in. N1 means in and N2 means out. It is I is similar to in, where electron in, and N2 means out. Okay, I it is one I, in, out, from where. So electron like orbit this is N1. N, this energy level. Okay, these two electron come here. So which one is N1? N1 is which orbit? This is the nucleus. N1 is this is energy level 1, energy level 2. Which one is N1? 1. Okay, N2? 2. Okay, good. Okay, I show this another. Okay, this one is nucleus. Okay, this is not. Which one is N1 and N2? Which one is N1? N2. N2 is 3. Good. N2 is 3. Good. So here is a in means N1. Out here electron. This N3. N2. 3. Okay, this energy level 1, 2, 3. So 2 is in and 3 is out. Okay, thank you. This scientist Rydberg give this formula. Okay, we'll use this equation. I will use this formula, 1 by lambda only. Use this one, 1 by lambda equal to here. Okay, what is RH? RH is a constant. It's called Rydberg constant. It's called Rydberg constant. Rydberg constant. Rydberg constant. Rydberg constant. Its value is 9678 per centimeter. What is the unit? Is per centimeter. This is the Rydberg constant. Okay. Okay, today we do this problem. Calculate what is chromatography. You know, this chromatography is a separation technique. Here different types dyes is separated, different types compound with different solubilities are separate. This technique. Okay, I will explain this thing, identification of compounds later. Ions and compound, in this chapter last topics these are. I'll explain this later. Okay, what is chromatography? Why does the 19 electron potassium enter its 4s orbital without entering into the 3d orbital? Already done, you know this thing. And calculate the number of electrons in the outermost shell of the stem. Okay, I have given a question. Okay, calculate the electrons in the outermost shell of the stem. Which one is the outermost shell? Shell N1, N2, N3. Which one is the outermost shell?
Number 2.
No, no. Outermost shell, ekdom বাইরে shell. This is N1, N2, N3.
Sir, N3.
Yes, N3. Here outermost shell means outside shell, ekdom বাইরে shell. N1, N2, N3 is the outermost shell. So here we will calculate the electrons. Okay, now question number C I am solving. Calculate the electron in the outermost shell. Raisa, take attendance and submit to my captain 1 to roll number. Anyone take these things and submit to my WhatsApp number. Okay,
Yes, sir.
okay, take attendance. Okay, this problem here. Okay, so question number C. Calculate the number of electrons in the outermost shell. Here principal quantum number n equal to what? Here principal quantum number n equal to what? N equal to what is the outermost shell? Here out
Sir, 3.
here outermost shell n equal to, okay, in outermost shell here in outermost shell n equal to 3. Okay, sorry, 3. So principal quantum number is here n equal to 3. So how we will calculate these things? Electrons we will calculate. Okay, you give this box this way, table you draw using table. This is the principal quantum number. This is the subsidiary quantum number. Then magnetic quantum number. Then here spin quantum numbers. Magnetic quantum number একটু বড় দেই, magnetic quantum number, magnetic quantum number, spin quantum numbers, electrons and total electrons. This is the principal quantum number. principal quantum number, here is n. Okay, here subsidiary quantum number or azimuthal quantum number, subsidiary quantum number L, then here magnetic quantum number. Okay, next is magnetic quantum number. Magnetic quantum number. This is M. Magnetic quantum number, then spin quantum number, spin quantum number, spin quantum number S. Okay, here question is called to calculate electrons number, total electrons number. Okay, so what is the principal quantum number? N equal to principal quantum number, n equal to what? N equal to given. What is principal quantum number? N equal to, what is the outermost shell here? N equal to, are you listening me? What is n value? Okay, here n equal to 3. Okay. Okay, what is the subsidiary quantum number? L value. If n equal to 3, if n equal to 3, what is L value? Hello student, unmute everyone. You are not talking. What will be L value? What will be L value? L value we know 0 to n minus 1. We know 0 to n minus 1. So if n equal to 3, what will be L? N minus 3 minus 1 means 2, means 0 to 2. 0 1 2, that means 0 1 2. Okay, okay, so I am writing here 0 1 2. Okay, now what will be magnetic quantum number? Okay, you don't need. Hey, stop your Keita. Another student call. Okay, so now magnetic quantum number M from L. Magnetic quantum number we find from L. M. Magnetic quantum number value is minus L to plus L. Okay. So first 0 is 0. No, there is no number. So 0 if I write only 0. Okay. Okay. For 1 is means minus 1 to plus 1. That means for 1 minus 1 0 plus 1. Okay. For my 1 it is magnetic. For this one, for magnetic subsidiary quantum number L, magnetic quantum number is minus L 1 0 plus 1. Okay, so what will be for 2? for two subsidiary L equal to 2, when what will be magnetic quantum number? It will be minus 2 to plus 2. What will be this? Minus 2 to plus 2. So what is the value? Minus 2, minus 1, 0, plus 1, plus 2. Okay, this is minus 2, minus 2, minus 1, 0, plus 1, plus 2. Okay, so we know this the L0, this which s orbital contain how many electron? 2 electrons, plus half. Each orbital contain 2 electrons and minus half. Okay, so this orbital, there is a 1, 2, 3 orbital. How many electrons can contain? 6 electrons. So how can I write? I write this 2 electrons here. I write here Doctor. Okay, 6 electrons. This is the 2 electron here. If I write here 3, it will be 6 electron. Okay, and if I write 5 and this way half, plus half, this is the minus half. Okay, this is the how many electrons? 2 are multiply 5, this is the 10 electrons. So how many electrons here in the here electrons? Here electrons is how many electrons here? How many electrons here? Plus half, minus half. Unmute student, how many electrons? This spin when magnetic no, this plus half, minus half, 2 electrons here. Okay, this here is a 2 electrons. Now here how many electrons? 6 electrons. Okay, here 10 electrons. 10 to 10. Okay, so what is the total electrons? Total electrons is 2 and 6, 8 and 10, 18. Okay, one question number 1 done. C done. Okay, calculate the number of electrons in the outermost shell of the stem. Done. Okay, now I'll do the next question is D, question number D. Okay, question number D I will do now. What will be color of the emitted ray if the electrons of the stem transmitted? This is the transmission occur from this higher energy orbit, this one, to electron transformer this orbit. So what will be color will be shown during this transmission? Analyze mathematically. Okay, so color, if we want to see color, we know which one will find, which one need to calculate to find color, which one need to calculate? Okay, we need to calculate wavelength. We need to calculate wavelength. Okay, like at first we will calculate wavelength. Oh, okay. If at first I will calculate wavelength. That's the okay. I will first wavelength. This look. This is look. This is color. I'll take wavelength like this is wavelength. Which is the color? The if a light white sunlight is fall in the prism, its light is splitted and form a combination of color. This is called a spectrum. This is the beep Geiger, violet color, indigo color, blue color, green color, yellow color, orange color, red color. So violet color wavelength is 382 400 wavelength range is 382 424 nanometer. If we find the 382 to 424 nanometer, like 381, I find this the color is violet color. If we find this range, any range, any wavelength between among this range, we will see indigo color is show. So we had first find out the wavelength. Then we should calculate wavelength. Okay, here which one is N1, which one is N2, where is electrons in and where is electron out, which one is in one? N1 is 2 আর N দুইটাও বলে দুইটা আছে দুইটা आंसर দিলে তো শেষ say anyone here in the stem electron move from third energy level to third energy level to move from third energy level to second energy level, so N1 equal to what is N1? N1 N1 3 not এখন বলো 2 এতে দুইটা আছে দুইটা অপশন শেষ হয়ে গেল N1 কোনটা ইন করছে ইন electron in 2 or 3 in and out. I said in means N1 and out means from where electron out from here or in is here in here from this word out this one. Okay, which one is N1? Where in electrons like here out and here in from 3 to 2. So where is in, where is out? If you don't say you will be unable to do this problem. What is N1? Okay, why Tafsir? Stop. Unmute. Mute. Hey, mute karo. Wahid. why tafsir? Are why tafsir? Okay, Arpita bolo, which one is N1 and which one is N2? Arpita?
N1 2
Eh,
and 3
3. Good. আচ্ছা তারপরে কি আছে সাবরিনা বলো which one is N1?
N1 2 N1 1 N1
আচ্ছা okay যাও N1 is a 2 and N2 is 3. Okay, so we will do this problem. So we know 1 by lambda equal to Rydberg constant N1 square divided by N2 square. Okay, what is the we know the Rydberg constant value is it I should write here RH equal to we know RH equal to koto. What is Rydberg constant? RH equal to 1078 per centimeter. Okay, so 109678. Okay, N1 equal to 2 and here is a 3 square. 1096 sorry 9678. Okay, 1 square 2 square means 4 and 3 square means 9. So what is 109678? Okay, 1 divided by 4 means calculator, scientific calculator is needed. 1 divided by 4 means 0.25. It is no 1 divided by 4 equal to 0.25 and 1 divided by 9 equal to 0.111. Okay, so minus these things. Okay, 1025 minus 11.25 minus answer equal to multiply 109678. So what is this value? 15,233. Okay, this one is found 0.05 is found. Okay, so 1 by lambda equal to this thing found. Okay, this thing found 1 by lambda equal to, so what will be lambda equal to? What will be lambda equal to?
1 divided by 153 105.
Okay, 1 divided by these things 1523305. Okay, divide these things. What result come? What come this? Are you dividing these things? 1 divided by answer 6.54 6.56 times 10 to the power minus 5. Okay, what is the unit? Lambda unit. This is the wavelength found. What is the unit? No. We use Rydberg is the, what is the unit? Centimeter. What is the unit here? This one is no unit. This thing is no unit. Rydberg constant has a unit. So it was inverse centimeter. Here is the inverse centimeter, but here it changes. Inverse centimeter becomes centimeter. So unit is the, what is the centimeter? Unit is the centimeter. Okay. So this is the centimeter unit. Okay, I want to convert it meter. What I will do? কত দ্বারা ভাগ করব? মিটারে কনভার্ট করতে হবে 100 দ্বারা ভাগ করতে হবে। So I divided by 100. So it is now 6.56 times 10 to the power minus 7 হয়েছে 7 when minus 7 when divided by minus 7 it become meter. When I divided by 100 it become meter. When minus 7 it 5 to minus 7 it become meter. Here is the centimeter. Check properly. Okay, this now I turn this 9 point this point I take here. So it will become 10 to the power minus 7 become 10 to the power minus 9 meter. So we know 1 times 10 to the power minus 9 meter সমান 1 nanometer. 1 nanometer we know. So what will be 2 times 10 to the power minus 9 nanometer meter equal to how many nanometer? How many nanometer? 1 times 10 to the power minus 9 meter equal to 1 nanometer. 2 times 10 to the power minus 9 meter সমান how many nanometer? 2 nanometer. So what will be 656 times 10 to the power 9 meter equal to what will be? What will be this 656 times
6 nanometer.
huh? 656 nanometer. Okay, we have convert this meter into nanometer. So our wavelength I have found. Wavelength is the these things. Okay, wavelength is lambda equal to 656 nanometer. I have found these things. So wavelength found. So this wavelength match which ranges? 656 the violet wavelength range is violet color is 382 424, indigo 424 to 450, blue these things, green, yellow, orange, red. Okay, which range matches this color? Our wavelength. देखिए our wavelength is 656. Okay, red matches. Okay, So we write this the red color wavelength ranges nanometer. Red color wavelength ranges. Red colors wavelength ranges. Red colors wavelength ranges কত wavelength ranges 647 to 780 647 to 780 nanometer. So the color of the emitted ray will be, what will be? So the color of the emitted ray will be, so the color of the emitted ray will be red. Okay, have you understood this question? This problem solved. Thank you. What will be color of the emitted ray? So red color will be emitted ray. Okay, so I'll give this problem like homework. You solve these things. Okay, you will calculate electrons number this way. Okay, thank you for joining today's class. I'll give assignment later here.